Good morning, pre-algebra. Here is our joke for this morning. Something to think about. I'm not going to explain it. You got to think about it. What did 0 say to the number 8? What did the number 0 say to 8? Nice belt. All right. Think about it. Let it simmer. Soak down. Maybe you'll get the meaning. It took me a while to understand it. But as you think about the joke, please turn the pages to page 495. Again, I am just blown away at how quickly we are getting through our book. We're almost at page 500. Imagine that. Who would have thought you would go 500 pages into a math textbook? Crazy stuff. All right. What we're talking about today is multiplying and dividing monomials. Remember, monomials would be an example of this. It is a number, a variable, or a mixture of both that have an exponent, or that are being that has an exponent. So that would be an example right here of 4 to the power of 3, or if you remember, it could be x to the power of 3, or it could be 4x to the power of 3, or it could be 4x to the power of 3 times y to the power of 2. Those are all examples of monomials. So we're going to be talking about what do we do when we multiply them and divide them. When you have a common base. And what I mean by common base is by looking here. Both are the numbers 4. Both are the numbers 12. In a moment we'll look at what happens when they are variables. But first, here's what we do. When we're talking about multiplying monomials, what it really means with a common base is we're doing 4, only one a common base, and then you add your exponents. So we would do 3 plus 5. 4 to the power of 3 times 4 to the power of 5. We then simplify it to 4 to 3 plus 5. So we end up with 4 to the 7th power. Excuse me, 8th. My goodness. 8th power. Okay, so whenever we're talking about dividing a monomial with a common base, you add the exponents together. So for example, here we have 12 to the power of 3 times 12. Now, to make it a little bit easier, I'm going to put a 1 up here, just so that may help you out. Again, it's kind of like just writing the x all by itself. It automatically means 1x. So you don't have to write the exponent, but maybe just for starting out, that may be helpful. So we have 12 to the power of 3 times 12 to the power of 1. So we're going to do 3 plus 1, so we end up with 12 to the 4th power. So, easy enough. With a common base, it means they have to be the same. You would add them together. You always add the exponents, and we're going to look at some examples. But please turn the page, and this is where we will see our example. So now I'm on the page 496. And what about when we have a variable b2 times b2? Okay, same thing. Common base, treat it just kind of like what we did with 4 and 12. And we're going to add our exponents, so that's going to equal b to the 4th power. Same with any kind of variable. However, if you look at example B, here is something a little bit trickier. We have 2x3 times 8x to the 4th. All right? So, what are our common bases? Well, our only common bases would be just x's. We do not include our numbers, okay? Because our exponent is only attached to one thing, and it's attached to the x. So, when we do this, it's really going to be written, I'm just going to draw it longhand, we really mean 2 times 8 times x cubed times x to the 4th. That's how we would write this out in a long way. And so what that's going to leave us with is we're going to end up with 16, and then our x stays the same because that's our base, common base. And remember, we add our exponent, so it's going to be 16x to the 7th power. Okay, so remember our first thing is we have to look at our common base. Our exponent is only attached to our x, so that's our common base. So we still multiply the number 2 and 8, so you get 16x. Those don't just disappear or become kind of random. That's how we solve it. Okay, let's. I want to do just one more example. So if I'm looking at the, let's see, that's example 2b. We have 5a squared times negative 3a to the 4th. All right, so parentheses means that we're multiplying. So I'm going to write this out longhand. So we really have 5 times negative 3 times a squared times a to the 4th. All right, so I'm going to have negative 15a and add them together to the 6th power. All right, and that is our final answer. So that's how we solve our problem. So whenever we multiply monomials, we're adding the exponents. Now if you look at the bottom of the page, what do you think we do when we divide? Just guessing, because division is the opposite of multiplication. So we have 8 to the 5th over 8 to the 3rd. What do you think? I'm thinking subtract, obviously, because it's the opposite of addition. So we're really going to have 8 to the 5th minus the 5 minus 3. So it's going to be 8 over 2. So division, when we're talking about, division of exponents, we are subtracting the exponents. So just a random one off the top of my head, we're going to have b to the 7th power divided by b. Alright, so remember plug in that 1 just if you need it to. So we're really going to have b to the 6th power. Alright, think that makes a little sense. Okay, raise your hand if not. And it's also going to be true for if we have a more complex kind of problem. For example, 4a cubed over negative a. Or we don't really see it like that. We'll do a negative 4a over a cubed. Alright, so what this really means is we're going to do our negative 4 is going to be divided by 1. So that kind of stays the same. But we're going to have a to the 1st power. And since we're doing a negative times a positive, remember there's kind of an invisible 1 there as well. Negative divided by a positive keeps it negative, so we're still going to have negative 4a, but we're doing subtraction, so it'll be squared. Alright, so that's the process. Again, it works just the same with numbers as it does variables. Alright? If you have any further questions, please raise your hand for help. Remember, continue to think about why 0 says to 8. Nice belt. You never know. Keep thinking about it. Alright, I will see you in real life.